Okay. So now we proceed with the special cases of your Routh-Hurwitz criteria. Okay, in which dalawang special cases yung pag-uusapan natin. Okay. Number one uh is that the row table can sometimes will have a zero only in the first column of a row. Okay, so sa isang row, yung first column nun magsi-zero. Okay? So naging special case yun kasi kung maalala nyo, lahat ng yung elements natin sa first row, ginagamit natin as a divisor para makuha nyo yung next row. Okay? So kapag ka nag-divide by 0 kayo, syempre magkakaroon ng problema dun. Okay? Or number 2, the row table sometimes will have an entire row of zeros that consists of will have an entire row that will consist of zeros. Okay, so yun yung dalawang special case na pag-uusapan natin. Okay, so for the first one, 0 only in the first column. Okay, if the first element of a row is 0, okay, division by 0 would be required to form the next row. Okay, to avoid this phenomenon, an epsilon or this symbol, okay, is assigned to replace the 0 in the first column. Okay, then the value of epsilon is then allowed to approach 0 from either the positive or negative side, after which the sign of the entire of the entries in the first column can be determined. Okay, so halimbawa meron tayong case dito. Okay, so let's determine the stability of the closed loop transfer function of this one. Okay, so kapag tiningnan natin yung ating row table for this one. Okay, so we will have we will have okay, so we will have 1, 2, 3, 6, 5, 3. Okay, as yung coefficients ng natin, ng ating closed loop transfer function. Okay, now so evaluating ito, okay, we will have 2 times 6 minus 1 times 3. Sorry, 2 times, mali pala. 2 times 3, okay, minus 1 times 6 divided by 2. So this is 6 minus 6 over 2, that's 0. Okay, then bago kayo conclude, okay, ng either itong first case o second case, tingnan nyo muna yung susunod na element. Okay, so yung susunod na element dyan is 2 times 5 plus minus pala 1 times 3 divided by 2. So that should give you 10 minus 3, that's 7 over 2. So ito yung 7 over 2. Okay, and then obviously itong pangatlo to is 0 na. Okay, so in which case meron kayong 0 on the first column. Okay, so kahit na 0 ito, okay, ito hindi to 0, non-zero ito. So this falls under the 0 only in the first column case. Okay, so ito yung first special case na gusto nating i-tackle. Now, ang problema nga nito is that kapag 0 ito, yung next row natin is evaluated by dividing 0 dun sa ating elements sa next column. So that would not be possible. So ang gagawin natin is that we replace that 0 with a number called epsilon. Okay, yung epsilon na yan is made to be a very very small number. Okay, a very very small number. Now either siya ay positive or siya ay negative. Okay, so tingnan mo natin ano mangyayari kapag naging epsilon yan. So we will evaluate now ito as 6 epsilon, okay, minus 2 times 7 halves, so that is 7 divided by epsilon. Okay, and then ito, okay, again this would be 3. Again, this is 2 epsilon tapos 3 tapos 0. So ito pwede natin i-carry over dito. Okay, so next we will have ito yung medyo complicated dito ng konti, no? So we will have 6 epsilon minus 7 divided by epsilon, okay, times 7 over 2, okay, minus 3 epsilon, okay, divided by 6 epsilon minus 7 divided by epsilon. So pag in-evaluate natin siya by some algebraic manipulation, makukuha natin ito. Okay, so paki-verify na lang kung tama. Okay, and then of course this is 0 na dahil 0 itong dalawang to. Okay, and then 0 din to dahil 0 na yung kasunod niya. And then finally, para dito we will have this to be carried over here. Kasi nga, ito, at saka ito. Ito, tsaka to, 0. So, ito, pwede rin ibaba dito. Okay. So, now, we are now able to evaluate ng first column. Okay. We are now able to evaluate itong first column natin. Okay. So, what would happen then is that itong epsilon, papalitan natin siya ng very small positive or negative number. So, kukunin natin yung first column ngayon dito. Okay, and then, tingnan natin ngayon. What if this is a very small number na positive? So, positive siya. I-assume natin na yung epsilon natin is positive. Now, if this is a very small number, itong 6 times a very small number would be actually very small. Okay? So, you can imagine na itong epsilon nyo is actually, halimbawa, positive 0.0001. Okay? So, pwede nyo gamitin nyo to evaluate here. Okay? So, halimbawa, 6 times positive 0.0001 minus 7 over ito. Okay. It would turn out na pwede natin i-check yan using your calculator. So, yan. So, ginamit natin yung calc function. Okay. So, tinamit natin 6x minus 7 over x. Calc 0.00001. Okay. Turns out na negative siya. Okay. So, lalabas ngayon, negative itong negative siya. Okay. So, pwede nyo gawin yun sa mga susunod. Okay. By assigning a certain small number dun sa ating epsilon. Okay. So, then, malalaman natin na yun na nga, positive, negative to. Tapos ito magiging positive, ito positive. Okay. So, we will find out na meron 2 sign changes. So, we will have a sign change here, from here to here. Okay. And then from here to here. So, we have 2 sign changes. Okay. Okay. So, kapag ginawa nyo siyang negative, ganun din. Makakuha rin kayong dalawang sign changes. So, kung negative ito, sabihin natin gawin nyo yung negative 0.00001. Okay. So, dito pa lang, from here to here, magiging negative na siya. Kasi nga, negative yung inassign yung number. Pero pag kinumpute nyo yung next, magiging negative, magiging positive na siya. And then ito, magiging positive na rin and so on. So, magiging dalawang sign changes na yan. Okay. So, either yung epsilon nyo is positive or negative, you will have 2 sign changes, and therefore there will be 2 sign changes. So the number of sign changes is 2. Therefore, the number of poles at the RHP is 2, and the number of poles at the LHP is 3. Okay? 3 kasi dapat yung number of poles sa RHP tsaka sa LHP all in all dapat maging 5. Dahil S raised to 5 yung pinakamataas nating degree. Okay, so you will have that one. Now, so medyo napansin nyo na medyo hindi ganun kadali na maglagay ng epsilon kasi nga nagiging algebraic siya. Okay. So para numerical pa rin yung solution niyo. Actually, in the evaluation of the Routh table or kapag in-evaluate itong Routh table, pwedeng ito directly palitan niyo na to ng number na maliit. Palitan nyo na kagad siya ng 0.0001. Okay? Instead na gawin nyo pa siyang epsilon. Kaya lang, dalawang beses natin gagawin ito. Isang positive, isang negative. Okay? So, ayun. Halimbawa, ito na nga yung natin, yung ating Routh table. Sinimulan ko na siya. Okay? So, 1, 2, 3, 6, 5, 3. So, again, pagka kinumpute natin ito, okay, itong part na to, this becomes 0. Okay, pero in this case, instead na 0 yung instead na epsilon yung ipapalit ko sa kanya is 0.0001 instead. A positive small number. Okay, so that pag kinumpute natin ito ngayon, that becomes 0.0001 times 6, okay, minus 2 times 3.5 divided by 0.0001. So that should become negative 63,994. So yun yung lagay natin dito. So let us make this as negative 63,994. Okay, and then ito magiging 3 na to kasi ito i-bring down na lang natin to dito. Okay, again 0 kasi ito. Okay. Now in this case this becomes that should become negative 994 times 3.5, okay, minus 3 times 0.0001 divided by 63 or negative 63994. That should give us 3.5. Okay, positive 3.5. So you would have 3.5 here. Okay, and then ito ay 0. Okay, this is 0. Dahil 0 itong dalawa, so 0 ito. And then this becomes 3. Okay, so from there, makukuha natin ngayon na meron tayong isa. Okay, and then dalawang sign changes. So you know, the number of sign changes na meron tayo, the number of sign changes na meron tayo equals 2. Okay, so therefore the number of right half plane poles, okay, is 2, and then the number of left half plane poles is 3, kasi 5 itong ating highest degree. Okay, now ang gagawin nyo ngayon is uulitin natin yan, but this time this is negative. Okay, this is negative now. Okay, so tingnan natin. Okay, so in this case, again, papalitan natin to ng na yung 0 dito. Okay, papalitan natin ng negative 0.001. Okay, and then still this is 3.5. So ngayon, pag kinompute natin ito, that should become negative 0.0001 times 6 minus 2 times 3.5 divided by negative 0.0001. That should give us 70,006. So dapat ito maging 70,006 ito. Okay, so this is 70,006. Okay, and this one is still 3. Okay, kasi mabibring down natin siya dito. Okay, this one, okay, becomes 6 times 3.5 minus 3 times negative 0.0001 divided by 70,006. That should give us 3.5 din. Okay, so this is 3.5, this is 0, and then this is 3. Okay, so again, counting the number of sign changes, you would have 1, okay, and then 2. So you still have the number of sign changes, okay, to be 2. Therefore, the number of right half plane poles is equal to 2, and the number of left half plane poles equals 3. So ganun pa rin. Okay, so whether we change it with a positive or negative number, yun yung natin, yun yung makukuha natin. Okay, and still, instead of changing this to epsilon directly, palitan nyo na siya kagad ng small number. Okay, so it won't una, mas madali ito dahil numerical pa rin yung solution niyo. Okay, that's number 1. And number 2, it doesn't change yung yung ating results. Okay, so yun nga lang, kapag ganito, pwede palitan niyo siya ng positive tsaka ng negative number para sure kayo na dalawa lang yung na pareho yung results niya. Okay, now paano pagka hindi pareho? Actually, napakadalang nung case na hindi yan magpapareho kasi syempre fix naman yung location ng poles niyo. Okay, hindi naman nagbabago yung location ng poles niyo. Depende diyan sa epsilon. Okay, kumbaga, pag binigay sa inyo yung polynomial, fix na yung location ng poles niyo. So supposedly dapat hindi mabago yan. Okay, so I don't know kung merong case na yan ay nababago. Okay, although there is still this very small possibility na baka mabago siya, especially kung medyo alanganin yung location ng isang pole, lalo na kung nasa gitna talaga siya, okay, or yung malapit talaga siya sa gitna, so baka pwede. Okay, pero as of now, sa tagal nating tinuturo itong hindi pa naman ako nakaka-encounter ng na nagpalit ito ng results. Okay, or yung mga ganitong case nagpapalit ng results. Okay, So that's one way we can solve this case na meron tayong 0 only in the first column. Okay. So ayan. May alternative dyan. Okay. May alternative way of actually solving that case. Okay. That is we obtain a polynomial that has roots reciprocal of the original polynomial. Okay, which may not arrive at a Routh table with a 0 only in the first column. Okay, so ang gagawin natin is ganito. Kung meron tayong polynomial, okay, at meron siyang roots, okay. Pag kinuha natin yung reciprocal ng roots natin, hindi naman napapalitan kung nasaan nakalocate yung poles natin. For example, ganito. Yan. For example, real poles man tayo, pero this also applies to imaginary poles or to complex poles, okay. Pero sa real poles, kapag meron kayong poles sa -2 at -3. Pag kinuha niyo yung reciprocal nitong -2, that becomes -1/2. Okay, kasi pag kinuha niyo yung reciprocal nitong -3, that becomes -1/3. Tama ba? Okay. Now, mapapansin niyo na negative pa rin sila. So ibig sabihin, hindi siya nagpalit ng location. Nagpalit siya ng location pero hindi siya nag-crossover sa right half plane. Kumbaga, nandito pa rin yung -1/2 tsaka -1/3, nandito pa rin sa right half plane. Okay, so ito yung -1/2 ninyo. Ito yung -1/3 ninyo. Nasa left half plane pa rin siya, sorry. Nasa left half plane pa rin siya. Okay. So, pero what happens kapag ang kinonsider natin is itong reciprocal ng roots ninyo? Okay. Tingnan natin muna ito. Kung ang roots ng polynomial ninyo ay -3 tsaka -2, yung polynomial that would result to those roots are s plus 2 at saka s plus 3. Okay? So, verify natin na itong s plus 2 at s plus 3 would give rise to the roots -3 at saka -2. In which, pag minultiply natin to, this becomes s square plus 5s plus 6. Okay? Pero, pag tinignan natin itong polynomial na panggagalingan ng mga roots na to, that should be coming from s minus 1 or s plus 1/2 at saka s plus 1/3. Okay, in which pag minultiply natin yan, that becomes s square plus 1/2 plus 1/3. Okay, pag inad natin yung 1/2 at saka 1/3, 1/2 plus 1/3, that should be 6 ang LCD. So this is 3 plus 2. 3 plus 2. So that should give us 5/6. Okay. So this is 5/6s plus this is 1/6. Okay. Or pag minultiply natin to sa 6, basically. Okay. Pag minultiply natin to sa 6 para ma-eliminate yung mga fractions. Okay. This becomes 6 s square. Okay. Plus 5s plus 1/6. Okay. Ngayon, pansinin natin ito at saka ito. Okay. Anong mapapansin natin sa coefficients nila? Mapapansin nyo na kung ito, kung isusulat natin sa array yung coefficients, so that is 1, 5, 6. Okay. Ito naman, kung isusulat natin sa, ignoring the denominator, okay. Kung isusulat natin sa sa array yung nito, this is 6, 5, 1. Okay. So, ang papansin natin na yung inyong coefficients, okay, pag in-arrange natin yan in reverse, okay, in reverse, yung roots nun, okay, would actually be the reciprocal of the roots of the original polynomial. Okay? So, ito yung isang technique na pwede natin gamitin ngayon dito. Ang gawin natin is isulat natin itong denominator nyo, okay, instead using the reverse coefficients. Okay? So, In that way, makukuha natin yung location ng reciprocal ng roots. And again, kung yung reciprocal ng roots nyo naman is hindi naman nababago yan kung nasa left half plane siya o nasa right half plane siya. Okay. So dito, kung ito yung binigay sa ating ito yung binigay sa ating denominator, okay, in which ang ating coefficients ay ang ating coefficients ay 1, 2, 3, 6, 5, 3. Okay. Sulat natin siya ngayon as yung reverse niyan. Okay, which is 3, 5, 6, 3, 2, 1. Okay. So, yan yung susulat natin ngayon. Or yan yung ilalagay natin ngayon sa route table natin. Okay. So, in which case, we will have the following. So, ayan, 3, 5, 6, 3, 2, 1. Okay. In which, kapag pa-verify na lang, na kapag kinumpleto nyo yung route table, wala kayong may encounter na 0 only in the first column. So, kapag gano'n, di mas maganda. Pero, don't, possible pa rin na mag-0 only to on the first column. Posible pa rin yan na kahit balik na rin siya, ganoon pa rin yung mangyayari. Okay? So, ayun. Pero in this case, hindi kasi nangyari yan. So, mas maganda. So, dito, mababasa natin na meron pa rin 2 sign changes. So, meron tayong dalawang sign changes dito. Okay, so ito, tsaka ito. Okay, so, merong 2 sign changes. Okay, meron 2 sign changes from here to here, tapos from here to here. So, yung number of sign changes natin is still 2. So, ibig sabihin, number of right half plane poles natin is still 2. So, yung number of left half planes pa rin natin is 3. So, papansin nyo, doon sa tatlong methods na ginamit natin, pare-pareho yung nakuha nating conclusions. Okay? So, that is meron siyang dalawang right half plane poles sa tatlong left half plane poles. Okay? So, yun yung mga methods ngayon na pwede nyong gamitin. Okay? Para ma-evaluate kung sakaling magkakaroon ng entire row, magkakaroon ng 0 dun sa first column ninyo. Okay? Una, epsilon. Pangalawa, magpalit kayo ng very small positive at saka very small negative number. Pangatlo, i-reverse nyo yung coefficients ng polynomial ninyo. Okay, so those are the 3 methods na pwede nyong gamitin para ma-solve yung yung ating para makompleto nyo yung route table para dun sa ating 0 on the first column. Okay, so ayun. Now, let us proceed dun sa case na na yung entire row ninyo ang mag-0 ngayon. Okay, so yung kanina, first column lang yung nag-0. Okay, in this case, we will proceed now with the case na yung entire row ninyo mismo yung mag-0. Okay, pero ang gawin muna natin is that, let's proceed with an example in which papakita natin kung paano ko kumpletuhin muna yung route table. Tapos later on, kung paano siya i-interpret. Okay, so let's complete the route table for the following closed loop transfer function. Okay, so in this case, we will have 10 over s raised to 5 plus 7 raised to 4 plus 6s raised to 6s cubed plus 42s squared plus 8s plus 56. Okay, so initially, you would have 1, 7, 6. Okay, you would have 1, 7, 6, 42, 8, at saka 56. Okay. So, yung 742 at saka 56, pwedeng i-divide yan ng 7 para maging 1, 6 at saka 8 siya. Okay. So, obviously, pag kinumpit nyo ngayon yung tatlong elements na yan, magiging yan, 0, 0, tsaka 0. Okay. So, kasi pareho yung, identical yung first 2 rows eh. So, kung identical yung first 2 rows, obviously, yung pangatlong row nyo would be 0. Okay. So, paano natin kukumpletuhin ngayon kapag ka nag-0 siya? 0, 0, tsaka 0. Ang gagawin natin is babalikan natin yung nasa naunang row, yung preceding row. Okay. Tapos, from there, magsusunod tayo ng polynomial galing doon. Okay? So, yung polynomial na galing doon, isisimulan natin dito. Okay? Which has, ito yung coefficient ng s to the fourth. Tapos, magdi-decrease yan ng dalawa. Okay? So, magdadaktaw yan ng power of s. So, kung s to the fourth ito, s square ito, tapos ito, constant to. Okay? So, ganun din dito, pag i-interpret nyo to. This is s to the fifth, s cube, tapos s ito. Okay? So, since ito yung concern natin, itong s to the fourth row, this is s to the fourth plus 6s square plus 8s, plus 8. Okay, so ito siya. Now, what we will do from there, pag nakuha na natin yan, okay, is we will differentiate this one. So, yung derivative nito with respect to s is 4s cubed plus 12s. Okay? So, yung 4s cubed plus 12s, yan yung ipapalit natin. Itong 4 at saka itong 12. Yan yung ipapalit natin dun. And of course, dito 0. Okay? Papalit natin yung 0. But itong 4 at saka 12 kasi is divisible by 4. So, palitan din natin, divide that to by 4. So, magiging 1 siya. And then, divide natin itong 12 by 4. Magiging 3 siya. So, ngayon, ang magiging, row nyo ngayon dito is 1, 3, at saka 0 na. Okay? And then, pwede na kayo mag-proceed ulit. Okay? So, you continue on that by completing the route table. So, ito yung magiging completed route table ninyo. So, paki-verify na lang. Okay? Yun. Okay? So, now, that's how we complete that's how we complete the route table of the case where meron kayong entire row na 0. Okay. So, paano natin siya i-interpret ngayon? Ganito. An entire row of zeros will appear in the route table when a purely even or a purely odd polynomial is a factor of the original polynomial. Again, magkakaroon lang kayo ng entire row of 0 kung yung original polynomial nyo is factorable into factors, one of which is a purely even or a purely odd polynomial. When you say purely even polynomial or purely odd polynomial, it means halimbawa yung s to the fourth plus yung nakuha natin 6s square. Okay, 6s square plus 8. So, purely even polynomial siya dahil yung powers ng s niyo are all even numbers. I-include nyo na rin yung s raised to 0. Okay. So, kapag pag ito, yung isa sa mga factors ng polynomial nyo, or ng original polynomial niyo, magkakaroon ng entire row of 0 sa kanyang route table. Okay. So, what would happen next is this. Itong even polynomial nyo ngayon, okay, yung even polynomial nyo ngayon, pag kinuha nyo yung poles niyan, okay, since even nga siya, ang mangyayari dyan is yung mga poles niyan symmetrical. Okay. So, kung symmetrical siya, ibig sabihin, halimbawa, meron siyang pole dito sa left half plane. Automatic na meron niyang counterpart na pole sa right half plane. Okay? O kaya, kung meron niyang complex pole dito at saka dito, okay, automatic na meron niyang asymmetrical dun sa kabilang side. Okay? Or, kung meron siyang pole dito sa j omega axis, magkakaroon siya ng counterpart dun sa ilalim. Kasi nga, symmetrical siya. Okay, so, even polynomial gives rise to symmetrical poles o symmetrical roots. Okay. And in that case, ito yung kaisa-isang case out of the 3 na diniscuss natin. Basic, 0 on the first column, at saka ito. Out of these 3 cases, ito lang yung case na magkakaroon kayo ng pole sa j omega axis. Ito lang yung possible case na magkakaroon kayo ng pole sa j omega axis. Okay. So that is why we should be in the lookout of the fact na kapag nag-entire row 0 kayo, kailangan open tayo dun sa possibility na meron tayong j omega axis poles. Okay. So ayun, yun yung isang dapat natin tandaan sa case na to. Again, yung entire row of 0 of the route table is due to the fact na yung original polynomial nyo has an even polynomial factor. Okay, in fact, in this case, okay, sa case na to, ito na actually yung pinaka-even polynomial factor niya. Yan na yun mismo. Okay. So, yung other niyan, meron pang isang factor yan in which that would correspond dun sa others natin. O dun sa other factor natin. Okay. So, ayun. Tapos, and then, this even polynomial, okay, would give rise to symmetrical poles o symmetrical roots. Okay. So, kapag symmetrical root siya, basta meron siya sa right half plane pole, meron din siya sa left half plane pole. Pag meron siya sa pag wala siya sa right half plane pole at left half plane pole, ibig sabihin nasa j omega axis siya. Okay? So ayun. Ngayon, ang gagawin natin kapag para ma-interpret natin ngayon, finally, yung ating route table. Okay. Ganito ang gagawin natin. Itong route table natin. Okay, lakayan natin. Ito yung route table natin. Nahatiin natin ito sa dalawang parte. Una, yung parte kung saan meron kayong even polynomial. So again, ang even polynomial nyo has a degree ng s raised to 4. Okay. So simula sa s raised to 4 pababa. Okay. S raised to 4 pababa. Yan yung even polynomial niyo. Okay. So that's 1. Yung other half nun is ito, yung others. So, simula dun sa taas hanggang dun sa even polynomial ninyo. Yan. Yan yung others ninyo. Okay? So, pag in-interpret natin siya is, i-interpret natin separately yung others at saka yung even. Pero tandaan nyo dun sa even, there exists this possibility na meron kayong j omega axis poles. Pero sa others, wala kayong possibility na ganun. Okay? So, yung others, we interpret it normally as the basic route table. Pero itong even, titingnan natin yung possibility na meron kayong j omega axis pole. So, paano siya? Ganito mangyayari. Sa even polynomial niyo, 'di ba wala kayong sign changes? Tama. So, kung wala kayong sign changes sa right half sa even polynomial niyo. So, even kaya natin sa even. No sign changes sa even. Kung wala kayong sign changes sa even, ibig sabihin wala rin kayong right half plane pole. Okay, wala kayong right half plane pole. Ibig sabihin wala kayong right half plane pole. Okay. Ngayon, dahil sa requirement ng symmetry, kung wala kayong right half plane pole, obviously, wala rin kayong left half plane pole. Okay, wala rin kayong left half plane pole. Kasi nga, kailangan, pag under ng even polynomial, kailangan symmetrical siya. Okay? So, kung wala kayong right half plane pole, wala rin kayong left half plane pole. So, kung wala kayong ng dalawang yan, nasan ngayon yung poles nyo? Nandun sa j omega axis. Okay, nasa j omega axis yan. At ilan ngayon yung nasa j omega axis niyo? Since ang even polynomial niyo has a degree of 4, at wala kayo sa right half plane at left half plane, lahat yun makikita nyo sa j omega axis. So, 4 yung makikita yung poles doon. Okay? So, ayan. That is for the even. Ngayon, yung others, we interpret it normally. Sa others, wala kayong right half plane, wala kayong sign changes. Okay? So, ibig sabihin, wala kayong right half plane pole. Okay? And then, lalabas ngayon, yung left half plane, left half plane pole ninyo, yung pole nyo, nasa left half plane ngayon. Kung wala siya sa right half plane, nasa left half plane siya. So, isa siya. Bakit isa? Kasi s to the fifth, okay, s to the fifth yung natin, yung ating degree. So, lumalabas ngayon, kung s to the fifth yung ating degree, ganito yan. Ito. Hati siya sa dalawa, no? Even. Ito yung mga possible locations natin. Left half plane. Okay. Tapos, we have right half plane. Tapos, meron kayong j omega axis. Okay. Tapos, meron siyang dalawang possible source. Okay. meron siyang even, meron siyang others, tapos i-total natin. I-total natin siya. Okay. Now, sa even, okay, i-total din natin to dito. Sa even, since 4th degree, yung total of number, since 4th degree yung even polynomial ninyo, 4 yung i-expect nating number of poles dyan. Okay. So, since lahat-lahat, dahil 5th degree yung original polynomial ninyo, 5 yung ini-expect nating poles. So, yung manggagaling yung sa others, isa na lang. Okay. So, ayun. Again, sa even polynomial, dahil 4th degree yung even polynomial ninyo, 4 yung inaasahan nating poles galing doon. Okay. Tapos, since 5th degree yung original polynomial ninyo, 5 yung poles na hinahanap natin. So, ngayon, kung 4 galing sa even, yung others ngayon, isa na lang yung hahanapin natin galing dyan. Okay. Ngayon, tingin tayo sa even. Again, walang sign changes. Therefore, as a requirement ng symmetry, walang right half plane at saka walang left half plane poles. So, ibig sabihin, itong 4 na to, nandun lahat yan sa j omega axis. Okay. So, ayun. Sa others naman, since walang sign change, walang right half plane pole. And wala naman tong requirement ng symmetry kasi ordinary ordinary or basic route table lang yung interpretation natin sa others. Okay? So since wala naman tong requirement ng symmetry, kung wala siyang right half plane pole, yung isang hinahanap nating pole nandoon sa left half plane. Okay? So that pag tinotal natin, meron kayong isang left half plane pole, wala kayong right half plane pole at meron kayong 4 na j omega axis. So all in all, meron kayong 5 poles. So that's how we account now yung distribution ng poles ninyo on the S-plane for this polynomial. Okay? So, ayan. So, pwede natin i-verify yung yung results. Okay, dun sa ating sa MATLAB. So, here, makikita natin na meron kayong pole dun sa na negative 7. Okay, which is a left half plane pole. Okay, so ito yun. Okay. And then, makikita natin na meron tayong pole dito na 0 yung mga imaginary, yung mga real parts. So, ibig sabihin, puro imaginary pole lang siya. Which means, nandun siya sa j omega axis. Okay, so makikita natin ito yun. At makikita nyo na ito yung mismong j omega axis kasi 0 yung real part. So, ito, 1, 2, 3, 4. So, ito yun. Itong 4 na to. So, which means, meron tayong 4 na j omega axis poles as what the Routh-Hurwitz criterion predicted. Okay. And also, since yung ating mga poles sa j omega axis ay hindi magkakapatong, which means hiwa-hiwalay siya. Okay, it means hindi siya double pole sa isang location. This means that your system is actually a marginally stable system. It means mag-oscillate undamped system ito. Okay, mag-oscillate lang yan. Okay, so pwede nyo i-verify yan by obtaining the step response of your transfer function. So, medyo hindi lang dito, pero pagka tinignan yan, oscillating yan. Okay, na meron dalawang frequencies dahil dun sa pole niya na meron dalawang different locations dun sa ating j omega axis. Okay, so dalawang frequencies yan. Okay, so pwede natin makompute yung dalawang frequencies na yan later on. Okay. And ayun. So that verifies yung natin, yung example 5.6 natin. Okay, na tama yung sinasabi ng ating Routh-Hurwitz criterion. Okay. So let us work on example 5.7. So for this transfer function, okay, tell how many poles are in the right half plane, left half plane, and on the j omega axis. Okay, so actually ito na yung route table na ma-generate natin for this one. Okay, pero try natin i-regenerate siya para mas matutunan natin yung pag-generate ng route table. Okay, so in this case, inulit ko siya dito. Okay, so hopefully medyo maging maayos ito natin. Okay, so for the first part, we will have 1 times 12, so that's 12 minus 22 divided by 1. So that should give us negative 10. Okay, so this is negative 10. Okay, so this is negative 10. And then we will have, this is 39 minus 59. So that's negative 20. Okay, and then this is 48 minus 38. So that should be 10. Okay, and then this is 20. Okay. That's 1, that's again 0 to. So pwedeng ito i-bring down natin dito. Okay, so now this can be divided by 10 so that pwedeng ang lumabas na lang diyan is ang pwedeng lumabas na lang diyan is this is negative 1. Okay, this is negative 20. Negative 2. Okay, then this is positive 1. Then this is positive 2. Okay. And then for the next row, we will have negative 1 times 20, negative 22. Okay. Plus 2 divided by negative 1. So that should give you 20. Okay, this is 20. This is 20. And then yung next one is negative 59. Negative 59 minus 1 divided by negative 1. That should give you 60. Okay. So this is 60. And then the next one is negative 38 minus 2 divided by negative 1. That should give us 40. Okay. You have 40 here. And then yung susunod niyan is 0 na kasi 0 to. So this is 0. Okay. So again, yung 20, 60 at 40, pwede nating divide yan by 20. So this should become 1. Okay. This should become 1. Okay. This should become 60 divided by 20 is 3. Okay. And then yung ito 40 divided by 20 is 2. Okay, so gawin natin 2 ito. Okay, and then next here, this is negative 2. Okay, so you have maliliit na number na to, so dapat negative 2 plus 3 divided by 1. Okay, so that's negative 2 minus negative 2 plus 3. Okay, negative 2 plus 3 divided by 1. So that is 1. Okay. That would be 1. Okay. Then we will have 1 plus 2 divided by 1. So that is 3. Tapos ito, ibababa na lang natin dito. That becomes 2. Okay. So itong dalawang rows na to pareho. So alam natin na ito, at saka ito magsi-0. Okay. So, since identical yung s to the 5th row tsaka s to the 4th row, yung s cube row, magiging 0 yan. So, again, ang gagawin natin is, babalikan natin ito, si s to the 4th. Sulat tayo ng polynomial para dyan. So, that should become s to the 4th plus 3s square plus 2. Then, kunin natin yung derivative nyan with respect to s. That should become 4s cube. Okay, plus 6s plus 0. Okay. So, ngayon, ang ipapalit natin dito is 4 at saka 6. Pero divide natin siya by 2. So, that should become 2 and 3. 4 divided by 2 is 3. 6 divided by 2 is 3. Okay. So, ang ipapalit natin sa kanya ay palitan natin yan ng 2. Ito, palitan natin ng 3. And this is 0. So, tanggalin na natin siya dito. 0 din naman siya. Okay. So, to take note na yung yung even polynomial natin has a degree of s to the 4th. So that pamaya kapag nagano natin, ito yung i-consider natin na even polynomial. Okay. Tapos ito yung i-consider natin as others. Yan. Okay. So ito yung even, ito yung others. Okay. So ayan. Now, we continue on. Okay. So this is 6 minus 3. 6 minus 3 is 3 divided by 2. Okay. So, 6 minus 3 is 3 divided by 2. So, that's 1.5. I-decimal lang natin para hindi kayo masyadong ano. This is 2. Kasi bababa lang natin siya dito. Okay. And then this is 4.5 minus 4. Okay. So, that is 1.5 times 3 minus 2 times 2 divided by 1.5. That should give us 1/3. Okay. So, lagyan natin 0.3333. Okay. And then this is 0. Okay. And then finally, this is 2. Okay. So, again, 0 ito. So, mabibiring down na lang ito dito. Okay. So, now we interpret this, this table. So, ito yung makukuha natin ngayon dito, no? Okay. So, take note na pareho lang yung nakuha natin. So, 1, 1, negative 1, 1, 1, tapos 2, 3 halves siya. Okay. 3 halves siya dito. Pero ginawa kasi ng is minultiply niya to by I think minultiply niya by 2. Okay. Which is okay lang naman. Okay. So, kaya magiging, nangyari sa kanya, naging 3 ito, at saka ito naging 4. Ito, hindi na niya na minultiply. He could have multiplied this by 3. Okay. So, para maging 1 siya. And then, 4. Okay. And in any case, pareho lang naman din tayo na magiging results ito. Okay. Now, let's interpret this one. Okay. So, gawa tayo ng table dito. Okay. So, yung ating location ng pole can be sa left half plane. Okay. Pwede rin sa right half plane. At pwedeng sa j omega axis. Okay. So, dalawa yung source ng polynomials natin. Okay. So, lagyan natin ng total dito. So, pasensya sa table. Okay. So, ito total din to. This is even. And this is, others. Okay. Wait lang. Ayan, mas inayos natin. Okay. Now, take note na all in all, 8 yung hinahanap nating poles. Okay. 8 yung hinahanap nating poles. And, since ang ating even polynomial has a degree of 4, okay, yung total dapat sa even natin is 4. So, yung 4 manggagaling dun sa others. So, yan yung magiging distribution ng natin. Okay. Yan yung magiging distribution ng ating left half mga poles natin. Okay. So, okay. So, in this case, pagbabasahin na natin ngayon yung ating route table. Okay. Unahin natin yung sa may even. Okay, sa may even polynomial. Okay. So, doon sa even polynomial natin, wala tayong nakikitang sign changes. Okay. So, saan ba yung even? Simula s to the 4th pababa. Okay. So, since wala tayong nakikitang sign changes dyan, okay, we will be able to say na wala tayong right half plane poles. Okay. And since under ng even polynomial, magre-require to ng symmetrical poles. So, kung wala kayong pole sa right half plane under ng even polynomial, automatic wala rin kayong pole sa left half plane poles under ng even polynomial. Again, sa even polynomial, magre-require to ng symmetry. Okay? So, kung wala kayo dito, wala rin kayo dito. Therefore, itong 4 ninyo na poles na nasa even polynomial should be under ng j omega axis. Okay? Sa others naman, ito hindi ito nagde-demand ng symmetry. And isa pa, wala kayong makikitang j omega axis poles dyan. Okay? So, kung wala kayong makikitang j omega axis poles dyan, yung 4 na to is distributed between left half plane at right half plane. Okay? Now, tingnan natin mabuti. Dun sa others natin, from s to the 8 hanggang s to the 4th, makikita natin na meron kayong dalawang sign changes. From here, that's 1. And then from here, that's 2. So, meron kayong dalawang sign changes. And 2 sign changes sa basic route table natin means 2 right half plane poles. Okay? Now, since meron kayong 4, okay, na poles under ng others at dalawa doon ay nasa right half plane. Okay, yung isa doon, yung dalawa doon, nasa left half plane. So 4 minus 2, that is 2. Okay, so all in all, meron kayo ngayong dalawang, para sa system na to, meron kayong dalawang left half plane poles, meron kayong dalawang right half plane poles, at meron kayong apat na j omega axis poles. Okay, so yan yung distribution ng poles ngayon ninyo para sa system na ito. Okay, so ito yung makikita natin dito. Okay, so meron kayong dalawang right half plane poles, meron kayong dalawang left half plane poles, at meron kayong apat na j omega axis. Okay, now obviously, dahil meron kayong right half plane poles dito, okay, that should render your system to be unstable. Okay, so dahil sa may presence ng right half plane poles, that should render your system to be unstable. Okay, so ayan. Now, I would like you to do on your own itong example 5.8, 5.9 at saka 5.10. Okay, para mas magamay ninyo. At saka 5.11 pa pala. Okay. So para mas magamay ninyo yung paggawa ng route table, yung paggawa ng route table tsaka pag-interpret ng route table. So yung examples 5.8 up to 5.11 covers different cases ng route table ninyo, from basic hanggang dun sa 0 on the first column hanggang dun sa entire row na 0. Okay? So ayun. What I would like to discuss now is itong example 5.12, okay, which is now a design problem, okay, involving stability. Okay. So in example 5.12, we are to find the range of gain k for the system shown here that will cause the system to be stable, unstable, and marginally stable. Assume a positive k. Okay. So meron tayong system na to. Okay, meron tayong system na to in which iaalamin natin anong range ng k na siya ay stable, unstable, tsaka marginally stable siya. Okay. So ito yung sinasabi ko kanina na kapag magde-design kayo ng system, dapat aware kayo dun sa range of values of k na pwede siyang maging stable, maging unstable, at saka marginally stable. Okay. So una, i-ano natin ito. I-express natin ito as a closed loop transfer function. So this becomes yung t of s natin dito is k over s times s plus 7, s plus 11 plus k, or this is k times s cube plus 18 s square plus 77 s plus k. Okay, so ito yung magiging closed loop transfer function niyo. Now, if you now prepare and complete your route table, ito magiging route table niyo. So 1, 18, 77k. Tapos ito becomes 18 times 77, so 1386 minus k divided by 18. Okay, and then ito, bring down na lang natin dito para maging k siya. Okay. Now, since we assume k to be positive, okay, we assume k to be positive, we see that the elements of the first column are always positive except the s raised to 1 row. So, sa lahat ng to, positive to, positive to, positive to. Ito lang yung medyo, medyo mababago yung sign. Okay, depende sa value ng k. Okay. It can either be positive, 0, or negative. Now, if we set now k to be less than 1386, okay, if we set k to be less than 1386, all the terms, ito magiging positive din to. So therefore, lahat ito positive. Okay, and there will be no sign changes, and therefore, all the three poles of your system are in the left half plane. Thus, for k for k less than 1386, okay, your system is stable. Okay. Now, if k is greater than 1386, the s raised to negative 1 term in this first column is negative kasi mas malaki na siya sa 1386. Okay. There will be two sign changes. Okay. And hence, there will be two right half plane poles. Okay. for this range of k, your system is unstable. That is for k greater than 1386. Okay. Yung system nyo ngayon magiging unstable. Okay. Now, if k is 1386 itself, okay, or is equal to 1386, take note na yung system ninyo ngayon magiging 0. Itong value nito magiging 0. So, magiging 0 siya. Okay. So, which could, but not entirely the only possibility. Okay. Which could signify j omega poles. Okay. So, kung babalikan natin ngayon, kung 0 ngayon to, okay, kung babalikan natin to ngayon, okay, this becomes 18 s square plus 1386. Okay. So, kapag ginawa natin yung derivative niyan, with respect to s, that becomes 36s plus 0. Okay. So, yung 36 ngayon ang ipapalit natin dito. Okay. And then, ito, mapupunta lang yan din dito. Simply. Okay. So, we have now the following table. And, from here to here, okay, from here to here, walang sign changes. So, therefore, walang right half plane poles at wala ring left half plane poles because of symmetry. Okay. So, therefore, meron lang kayong dalawang j omega axis poles. Okay, galing dito. Tapos, from s cube hanggang s square row, since walang sign changes, wala kayong right half plane pole, so meron kayong isang left half plane pole. Okay. So, in that case, your system is then marginally stable kasi yung poles niyo isang left half plane, dalawang j omega axis. Okay. So, you may be asked, kung marginally stable siya, it would be oscillating. Okay. Ang tanong ngayon is, maaaring ang itanong sa inyo, ano ngayon yung frequency of oscillation? Okay. Yung frequency of oscillation is actually involves solving for S here. Okay. Kasi yung magiging frequency of oscillation yan is yung value ng omega. Okay. Yung magiging value ng omega n. Yun yung magiging frequency of oscillation niya. So, from here, we can actually solve for yung 18s square plus 1386. Pwede ninyong i-equate yan sa 0 para ma-solve nyo yung s. So, that should have your s to be yung s natin magiging square root siya ng negative 1386 divided by 18. Kasi hindi siya naka-complex. Okay, so pwedeng in negative j na lang natin yan namin. So that becomes 1386 divided by 18. So that should be 77. So yung s natin is basically plus or minus j square root ng 77. Okay. Yung frequency of oscillation ngayon na hinahanap nyo is ito. Yan ngayon yung omega n nung undamped oscillation niyo. That is square root of 77. Okay. So, yung location niya mismo dun sa ano. Kaya lang, this only works kung kung isang pair of j omega axis poles lang meron kayo. Okay. Kung meron lang isang pair of j omega axis pole lang meron. Pag yan ay nagdalawa, for example, meron na sa ibang location ito, marginally stable pa rin siya, pero yung frequency of oscillation niya is hindi na yung ano. Okay. In fact, composite na siya nung mga individual frequencies na to. Okay. So, ibang operations na yung gagamit natin to find the overall frequency of oscillation for this one. Okay. So, dito ngayon, pinaka-useful ang Routh-Hurwitz criterion sa part ng design. Kasi kung ito ay gagamitan nyo ng Octave or ng MATLAB para mahanap nyo yung K, hindi nyo basa-basa mahanap yan using the roots method. Okay. So, medyo mas mahirap yung mathematics kapag kaganan. So, mas madali siya kapag ginamitan natin ng route table in order to find the value of K for this one. Okay. So, that ends yung ating discussion about natin about Routh-Hurwitz criterion and stability. Okay. So, hopefully, this would be useful kapag next time maghahanap na tayo ng mag-analyze tayo ng stability ng ating system.